Hi, welcome back to another Examify walkthrough through an additional math paper 1 non-calculator paper. This paper is from May-June 2025. So the first question says that given that PQ equals -3, 7, and 4PR equals -2, 8, find RQ. So the first step to solving this question would be to find PR, which would be 1/4 of the given vector for PR. And to find RQ, we know that if we do RP plus PQ, it will give us RQ. And I obtained this by rewriting the vectors that are given to me, so I can cancel out the p's to get RQ. To get RP, we can do -1/4 -2, 8, plus -3, 7 as given in the question, and this will be RQ. So the vector RQ equals -2.5 and 5. Moving on to part B of the question, we're given vectors A, B, and C such that this, where alpha and beta are scalars. Given that the vector C equals 3 times the vector A minus 2 times the vector B, find the values of alpha and beta. The first step to solving this question would be to rewrite this equation by substituting in the formulas for vectors A and B. So this means 3 times the vector A is alpha I plus 6j minus 2 times the vector B, which is 4I plus beta j. So vector C equals 3 alpha I plus 18j minus 8I minus 2 beta j. Rewriting this would give me 3 alpha minus 8I plus 18 minus 2 beta j. If you notice, we now have an equation in the form of I and j similar to the one that's given in the question over here. So how to go about these types of questions is that you compare the coefficients of I and j. So I know that 3 alpha minus 8 equals 2 alpha plus 5 beta, as seen over in this part of our equation. And 18 minus 2 beta equals 20, as seen in the second half of the given equation. So we know that 2 beta equals -2, so beta equals -1. And substituting the value of beta into this equation, I get 3 alpha minus 8 equals 2 alpha minus 5. Alpha equals 3. So alpha is 3 and beta is -1. Moving on to question number 2, solve the inequality 3 minus x times 5x plus 8 is greater than or equal to 9 minus 3x. So the first step to doing this question is to open up the left-hand side, for which I get 15x plus 24 minus 5x squared minus 8x is greater than or equal to 9 minus 3x. I'll bring everything on the right-hand side over to the left-hand side to get minus 5x squared plus 10x plus 24 minus 9, which is 15 is greater than or equal to 0. So I get 5x squared plus 10x plus 15 5x squared minus 10x minus 15 is less than equal to 0. Solving this, I get 5 times x plus 1 times x minus 3 is less than equal to 0. So the critical values are -1 and 3, which means that the values of x are -1 greater than equal, x is greater than equal to -1, but less than equal to 3. Question 3 says, point A has coordinates 3, comma, -1. A circle has the given equation. Show that A lies on the circumference of the circle. So, since this is a show that question that's worth only 1 mark, the solution to this is pretty straightforward. You've been given the circle's equation in the format of x and y, so you substitute in the x and y values. 3 minus 4 squared plus -1 plus 3 whole square. You need to prove that this should be, if this is equal to 5, then it lies on the circumference of the circle. So -1 squared plus 2 squared. So you get 1 plus 4, which is equal to 5. Therefore, A lies on circumference. Part B says, given that AB is the diameter of the circle, find the coordinates of B. So, for reference, this is our circle where we have point A, and we need to find point B. To solve such questions, we first need to find the center of this circle. So I'm going to call the center of the circle C, which has the points C1 and C2. To find these coordinates, since we have the equation of the circle, which is x minus 4 squared plus y plus 3 squared equals, and to write this in the original form of the equation of the circle, I'm going to write √5 whole square. You know that the center of a circle is simply this and this number, because the original equation of a circle is x minus h whole square plus y minus k whole square equals r squared, where r is the radius. So we know that the center of the circle C's coordinates are 4 and -3. Since now we have the center of the circle, which is also the midpoint of A and B, we can use the formula H, which is C1, and for ease, I'm gonna call this H and K. HK. H is x1 plus x2 divided by 2, which is our midpoint formula, and K is y1 plus y2 divided by 2. We have x1, we have H, we have K, we have y1, we can find x2 and y2. So I can plug in the values where 4 equals 3 plus x2 divided by 2, and -3 equals -1 plus y2 divided by 2. So our coordinates of B are 5, comma, take this over, -6 plus 1 is y2. So y2, -5. Those are the coordinates of B. Part C says, find the equation of the tangent to the circle at A. So we need to find the gradient of the radius of this circle. So to find the gradient of the radius of this circle, we can take our center coordinates and our point A's coordinates. So the gradient is y1 minus y2 over x1 minus x2, which gives me minus 3 plus 1 over 4 minus 3, which gives me negative 2 over 1. So gradient equals negative 2. So the gradient of the tangent, because we have the circle, this is the radius at point A, and we need to find the equation of the tangent. So the gradient of the tangent times this tangent is perpendicular to the radius. So the gradient of the tangent equals negative 1 divided by negative 2, which means that the gradient is half. So the equation is y equals half x plus c. To find c, you substitute in the coordinates of A, which I'm going to continue over here. Sorry if it's so messy. Our coordinates are negative 1 equals half times 3 plus c, which means negative 1 minus 3 over 2 equals c. c equals negative 5 over 2. So y equals half x minus 5 over 2. And that is the equation of the tangent to the circle at point A. Question 4a says, solve the equation x to the power 1 over 3 minus x to the power 1 over 6 equals 2. The first step to any question that is phrased this way is that we bring everything to one side. After you do so, most of the time in non-calculator questions like these, there's always a trick, and here it is that if you notice, if you times this power by 2, you get 1 over 3. So that means I can use the substitution rule where I can call z equals x over 1 over 6, x to the power 1 over 6, sorry. So if I rewrite my equation, I can write it as z squared because z squared is x 1 over 6 times 2, which is x to the power 1 over 3. So z squared minus z minus 2 equals 0. And you can factorize this out to be z minus 2 times z plus 1 equals 0, which means z equals 2 or z equals negative 1. So x over 1 over 6 equals 2, or x to the power 1 over 6 equals negative 1. So using logs, or you could just power both sides by 6 in both cases. So you get x equals 2 to the power 6, or x equals negative 1 to the power 6. So however, at this point, although this is possible, you should reject this as soon as you see it, because if you rewrite this in the format of logs, it would look a lot like that, and that's not possible. So that's rejected. So our only answer is x equals 2 to the power 6, which means x equals 64. Part B is also chemical equations, where you're given a log in one of the equations. So how do you do this kind of question? First of all, you need to rewrite the log in normal format. So you know that it's saying log base 10 x plus 2y equals 0, which means that 10 to the power 0 equals x plus 2y, which means that x plus 2y equals 1. And now you have your other equation as well, which is x squared plus 4xy plus y equals 1. And now you can use substitution in this, where I'm actually going to substitute in the y. So y, or I'll substitute x actually. X equals 1 minus 2y. So 1 minus 2y whole square plus 4 times 1 minus 2y, 4y, plus y equals 1, to get to be 1 plus 4y squared minus 4y plus 4y minus 8y squared plus y equals 1. Rewriting cancels. Again, minus 4y squared plus y plus 1 equals 1. I take that one to the other side, so I get 4y squared plus y equals 0. I get y to be minus 4y plus 1 equals 0. So y equals 0, or y equals 1 over 4. And to find the complementing values of x, I'll just substitute in these values into this equation here. So x can be 1 when y is 0, and x equals 1 minus 2 times 1 over 4, which gives me x equals 1 minus half. So x is half when y is 1 over 4, and these are your answers. It's important that you write them side by side. You can split them with a comma and then write "and" in the middle, so that the examiner knows that you have two sets of answers and they are corresponding to each other. Moving on to question 5, where we have another solve the equation. So solve the equation 5 times absolute value of 2x minus 1 plus 8 equals 23. First step, I'm going to treat the absolute value as normal brackets, where I get 10x minus 5 plus 8 equals 23. 10x equals 20, x equals 2. And in the second I'm going to take a negative sign in front of 2x minus 1, so I get negative 5 times 2x minus 1. And the reason that I did this is because what does an absolute value do? It gives you the absolute positive value of whatever's inside the brackets. That means that if this were to be positive, then it would just be 2x minus 1 in my assumption. But if it was negative, then it would be minus of 2x minus 1, which is what I have done here. Plus 8 equals 23, minus 10x plus 5 plus 8 equals 23, minus 10 equals 10x, x equals minus 1. These are your two final values. The next question says, get the graph of y equals 5 sine x minus 2 for this range. So, again, no calculators, and I know that's hard, but for these types of questions, I would always recommend using a pencil first, because what you know about this is that you don't have any, you know what the basic sine graph looks like. So I'm going to draw the basic sine graph first. Which starts at 0 and okay, this is rough sketch, obviously. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's 1. Starts at 0, goes up to 1, comes back down, goes to negative 1, comes back up. And that is what our basic sine graph looks like. So what I've drawn here is the graph of sine x. But now what it wants us to do is it wants us to create 5 sine x. Well, it wants us to create 5 sine x minus 2, but I'm just going to draw 5 sine x first. And that just means that I multiply all of my y values in my sine graph with 5. So I'm going to do this in red. Starts at 0 still, but 1, 2, 3, 4, 5. We'll go all the way up till 5. Comes back at the same point, but now 1, 2, 3, 4, 5 goes all the way down to negative 5, comes back here. So it's really more like a big stretch. And well, it is a big stretch. But same points. Same x. That's now that is my graph for 5 sine x. What has happened? It has elongated 5 units. And minus 2, we know that if the minus 2 isn't inside any brackets and it's just outside, not inside the x function, then it is a horizontal shift downwards or upwards. In this case, it's downwards by 2 units, which means I'm going to shift my graph 2 units down. This goes there. That goes there. That goes there. This goes further down, and that's there. And again, they know that this is very freehand. So as long as you have your main points sketched in, then the examiner is going to give you the marks. And now you know that before my baseline was at 0, now my baseline is at -2. The blue graph is the final graph. Moving on to question 6. A curve has the equation y equals that. Show that the derivative can be written as that, where a is a positive integer to be found. Don't panic when you see questions like this. We're gonna go very slowly. Where we need to find dy by dx. So how would you do this? Well, first, I will find the derivative of whatever's inside my brackets here. Sorry, I completely got rid of the 4. Inside my brackets here. So d dx of x squared minus 1 over x squared plus 1, which will give me x squared plus 1 times 2x minus x squared minus 1 times 2x over x squared plus 1 whole square. Now we need to simplify what we have. And I'll do so with the denominator. So I have 2x times x squared plus 1 to the power -1, because these two have the same values inside the bracket. So I've just divided it and I've gotten, well, once you divide it, really what this is it's 2x over x squared plus 1, but I've written it in the form of powers just so that it's easier and more concise. And then I get minus 2x times x squared minus 1, which is what we have up here. In addition, we have x squared plus 1 to the power -2, which is our denominator. So this is the derivative of what's inside the brackets for the function y. Now, we need to correctly derive the actual whole function, which is dy by dx, which is 4 times, we're going to write the function 4 times x plus 1 to the power 3, because if y is x to the power 4, then dy by dx equals 4x cubed, as you know. And we're going to multiply this by the inside function's derivative. Because if you remember, or if you do know, when you're finding derivatives of functions, you always go from the outside to the inside. So you derive the outside and then you derive the inside and then you combine. So combining it is essentially multiplying them together, which is what I'm going to do right now. So x squared plus 1 times 2x. Oh no, I don't have space. Maybe I shouldn't have written it so big. Okay, I'll do that again. Dy by dx equals 4 times x squared minus 1 over x squared plus 1 to the power 3 times. Let's just take this bit here that we wrote down before. So times 2x x squared plus 1 to the power minus 1 minus 2x, x squared minus 1, x squared plus 1 to the power minus 2. And I'm going to fast forward, but you can simplify it all, and you get dy dx equals 16x x squared minus 1 cubed over x squared plus 1 times to the power 5, and that is our derivative, where a is 16, but you just need to write it in that format. Part BI says, show that the curve has stationary points where x equals -1, x equals 0, and x equals 1. So, what was our derivative? You know that a curve has stationary points when the derivative is 0, and the derivative that we obtain can only be 0 when the numerator is 0. So I'm going to take the numerator, 16x times x squared minus 1 cubed equal, and I'm going to equate it to 0. Therefore, x can be 0 from this bit. X can be 1 from this bit. And x can also be -1 because it's a square over here. And those are our 3 points. The next part says use the first derivative test to determine whether two stationary points have the same nature and state whether they're a maximum or minimum points. So let's make a table here. X we have -1 x 0 because we have these as our stationary points. So we're going to take all the cases, right? 0 itself, and we have 0 to x to 1. So dy by dx. Between -1 and 0, x is positive. And you know this because between -1 and 0, x is a negative value. And if you notice, our numerator will be negative because after you square the negative, then this whole bit will be positive. But this bit will be negative, and the denominator will, the numerator will also be positive because this bit will be less than 1. So negative, negative will give you positive, and the bottom will also give you a positive value. So that will be positive at 0, derivative is 0. And between 0 and 1, it is negative. Again, same logic that we used to derive whether this is positive or negative. And then we're going to draw another table. And this time I'm going to do 1. So I'm going to do 0 to x to 1, which I know I've done, but it's just going to make it easier. And 1 itself, and x is greater than 1. So dy by dx. Between that, it's negative. At 1, it's 0, and x is greater than 1 is positive. You can draw out the other table as well, but I'm not sure that you need to. So you can, or you know what, we'll do it. Let's draw that out. So less than -1 is negative. Add -1 is 0, and between -1 and 0, it is positive. So that means that x equals 1 and x equals -1 are min, and x equals 0 is max. And that is your answer. Question 7. Find the x-coordinates of the points where the curve this cuts the x-axis. Solution to this question by accurate drawing will not be accepted. Okay, so let's expand our y equation, for which you get 2x cubed plus 10x minus 9x squared minus 45 plus 42. So 2x cubed minus 9x squared plus 10x minus 3 is y. And if it cuts the x-axis, then y is 0. So you have 2x cubed minus 9x squared plus 10x minus 3 equals 0. You know what you need to do, and it is tiring to do this, but we have to. We have to find a linear factor. So how do we find the linear factor? Well, you could. We will take in, I'm going to take x equals 1 because I always start with x equals 1. So I get 2 here, 2 minus 9 plus 10 minus 3, and I get